Hi folks, welcome to day 24. Today we're going to be discussing section 5.4, which is all on equations that have difficult radicals in them. So earlier this week, what we've learned about is how to solve equations that have radicals and rational exponents. And we know that when we have those equations, we always have our same three steps: isolate, exponentiate, and then solve. We're going to have those exact same three steps today. They just might look a little bit more difficult, and they might look a little bit more challenging. But you can still get through them, so don't be intimidated. Let's go ahead and start off with something that looks like 2x minus 4, the square root of 2x minus 4, plus the square root of 3x plus 6 equals 0. So our first step is to always isolate. But in this case, we can't isolate since there's two radicals, right? You can't isolate a radical if there's two of them. But what we can do is we can isolate one radical on each side. So in the event that you have multiple radicals or multiple expressions that cannot be simplified that have rational exponents, then what you have to do is isolate one on each side of that equal sign. So in order to get my square root of 3x plus 6 to the other side of the equal sign, I'm going to go ahead and subtract that from both sides. So then we'll have the square root of 2x minus 4 equals the negative square root of 3x plus 6. All right, we've isolated. Now we need to exponentiate. Since I have a square root, I'm going to go ahead and exponentiate by cubing both sides. By squaring both sides. I would cube it if it was a cubed root, but I'm going to square both sides since it's a square root. And remember, when we square both sides, the square and the square root cancel each other out. The nice part here is on that right side of the equation, we have a negative square root times that negative square root. The stuff inside the square root's the same, so it still squares. It still gets rid of the square root just like normal, but it also gets rid of that negative. So on the left we'll have 2x minus 4, and on the right we'll have 3x plus 6. So we isolate, we exponentiate, then we solve. So in order to solve, all we got to do is combine our like terms. So I'm going to subtract my 2x over and also subtract my 6. So I have my 2x's cancels and my 6's will cancel. So on the left, I have negative 4 minus 6. That gets me negative 10. And then I have 3x minus 2x. That gives me x. So x equals negative 10. So those are the easier type. All right, you'll have one like those in my problems, and I'm sure those of you that have other teachers will have ones similar to that as well. All right, let's go ahead and go through example 2. Whew. So we have x plus 1 equals the square root of 7x plus 15. All right, so we're going to start by isolating the radical, but in this case, our radical is already isolated. Great. Part of why I picked this problem is because y'all can isolate the radical pretty easily. I'm really confident in your abilities to do that. All right, so we isolate, we exponentiate, then we solve. So exponentiation here, the power that we'll be raising, since we have a square root, we're going to square both sides. So I'm going to square all of that right side and all of the left side. All right, so I know that my square root's going to cancel on the right, so I'm left with that 7x plus 15. But on the left, there are still some of you that are trying to distribute this to make it an x squared plus 1 squared, remember that when you have a binomial, when you have two terms being added or subtracted together, you can't just distribute in a square. You instead have to do x plus 1 times x plus 1. You have to FOIL. FOILing our left side, we get x squared plus 2x plus 2. And our right side, we still have 7x plus 15. This is what I was talking about when I said that they get more difficult. So if you're confused from this step to this step, all I did was FOIL, first, outer, inner, last. You're not going to have to FOIL more than 2 binomials in my class. You might have something different in other classes, but just letting you know. All right, so we have x squared plus 2x plus 2 equals 7x minus 15. Now, in order to solve this, we have to get all of the x's and all of the numbers on one side. That's because we have to have our quadratic being equal to 0 in order to find the roots. This is drawing back to your ability to solve quadratics from your Advanced Algebra A. So whether you had that first trimester or if you had it regardless of whether or not you had it first trimester or if you had it second trimester. Also, I have an error here. For some reason in my head, I thought that 1 squared is equal to 2. It's not. It's equal to 1. That's going to make it a lot better to factor that. All right. So now I'm left with x squared minus 5x minus 14 equals 0. We go ahead and factor it. Remember, factoring, you just got to write out your factor tree. So I have negative 1 and 14, 1 and negative 14, negative 2 and 7, and then 2 and negative 7. Adding those together, we get 13, negative 13, 5, and negative 5. I was looking for negative 5, so since that's what I was looking for, that's what I'm going to use down here at the bottom. So I have 2 and negative 7 as my factors. So I have x plus 2 times x minus 7 equals 0. All right, now that I've done that, I set each piece equal to 0, which changes the signs. Y'all know how to do that because you did it very well in our previous tests and our previous quizzes. All right, so we have x equals negative 2 and x equals 7. But here's where it gets interesting because we're not done yet. There's an extra step when you have more than one answer. Anytime you're solving an equation that has a radical or a rational exponent and you have more than one answer, you have to check to see if either of the answers are extraneous. An extraneous answer just means that it's an extra answer. It doesn't work when you plug it back into the original equation. So even though the algebra thinks it works, it doesn't actually work because it doesn't make the equation true. And that's because, remember, anytime we're squaring things, right, this squared, that results in a positive and a negative answer, right? Anytime we're taking square roots, that's positives and negative answers. So that's why we have lots of different things to worry about when it comes to this extraneous piece. So when you have an extraneous answer, all that means is you take your two answers, so we have x equals negative 2 and x equals 7, and then you take your original equation. So we have x plus 1 equals the square root of 7x plus 15. All you have to do is plug in each answer into that equation. So we have x plus 1 equals the square root of 7x plus 15. All right, so we're going to try that with x equals negative 2 and x equals 7. I'm going to go ahead and start with x equals negative 2. So I have negative 2 plus 1 equals the square root of 7 times negative 2 plus 15. Well, negative 2 plus 1 is negative 1 equals the square root of 7 times negative 2 is negative 14 plus 15. the square root of negative 14 plus 15, well, we can go ahead and combine those to get to get positive 1. So we have negative 1 equals positive 1. Negative 1 doesn't equal positive 1, so that cannot be our answer. You can go through and check this, but you would get 8 equals 8. I'm not going to walk you through it. I'm confident you guys can do that yourself. I also have it in my written notes as well. But when you have 8 equals 8, that's always true. So x equals 7 is the final solution for that. All right. So what you're going to be doing today in your problems is isolating, exponentiating, and then solving. Sometimes you're going to immediately get one answer like we did here with that x equals negative 10. Sometimes you're going to get more than one answer. If you get more than one answer, you have to check to see if it's extra. If it's extra, it'll give you an invalid answer like negative 1 equals 1. That's never true. So that's how you get your whether or not an answer is extraneous. So that's all I have for you today. Good luck on those practice problems for you to try out. Talk to y'all tomorrow.